I start to speak English because our next speaker is Joep Orbans, who works in the ArcheoPro company of the University of Leiden, the Netherlands. Joep, we invite you with your presentation about combined geophysical surveys on medieval and post-medieval build structures.
So, welcome and thank you for the invitation, Dmitry, for this very nice conference in Moscow. I'm going to talk about a combined geophysical survey on medieval and post-medieval built structures. I'm first going to give an introduction, then I'm going into some of the cases that I have surveyed, and then breaking down the data into the information available, and then draw towards a conclusion. Well, let me introduce the Netherlands as an archaeological country, the archaeology of the Netherlands. And it's a more or less modern country, and most of the archaeology is from medieval and post-medieval constructions, buildings, like castles, churches, chapels, and monasteries. Of course, there is some Roman parts, and of course, we do have quite a lot of prehistoric archaeology, but the most visible parts are these medieval and post-medieval structures. These consist mostly of brick foundations. We have very rare use of sandstone and limestone. There is a little bit, but not a lot of it. So it is mostly brick foundations. And this results in high resistivity of underground structures, and of course, being brick, it does produce a magnetic anomaly. Well, being fortified countries, being fortified structures, a lot of these also have a wet moat around it, and these wet moats have been infilled after the building collapsed or was came out of use, and so these moats filled in with peaty substance, therefore resulting in low resistivity filling of these moats, therefore creating a contrast with the high resistivity of the walls. Of course, these wet infilled moats do not produce a magnetic anomaly, so they are very hard to find in the magnetic geophysics. Well, this information, this sort of archaeology of brick foundations, wet moats, and all of this does produce a very high contrast in geophysics. So for geophysical surveys, this should be easy to do. It should stand out like a flashing light. There's archaeology down here. But as I will present in this presentation, that things do get a bit complicated with us. Well, fortunately, being medieval and post-medieval, we do have a lot of assistance. We have a lot of assistance from historical maps. And I have seen in some of the other presentations yesterday and today that it is the combination of data that does give some archaeological information of the site. The use of these historical maps is very, very important to understand the archaeology, to understand the results of geophysics, the understand of remote sensing data. The historical maps are absolutely important, and we use them all the time. And we have a very high amount of historical maps dating back to the 18th, 17th century. We also have a lot of local historical societies, and these local historians, mostly volunteer people, they have spent all of their lives into that area. They spend hours and hours, days and days in the archives, and they can go through all of these data and find a lot of information. They find these historical maps. So that is very valuable to use these local historical societies. They have a ton of information that you really need to understand the site, because we have only limited time to do a certain survey on a site. So that is very helpful. And of course, they are very helpful in the field as well. And here they are carrying out an EMI survey and it was the amateurs doing the work, and I could sort of relax and enjoy the area. So that was very helpful. For this presentation, I took 22 sites I have surveyed over the last 5 years. These sites are spread all over the Netherlands. So in the right and bottom corner, you see a map of the Netherlands with the locations marked. Most of these sites are in the south of the Netherlands. That is a coincidence. So sometimes I do survey in the north as well. It depends on what sites become available. And as you can see in these 22 sites, it goes all over the country. And as you can see, all of these sites were surveyed with EMI. And with EMI, that is usually the CMD Mini Explorer that works till 1.5 meters below the surface. But sometimes I also use the EM31, which goes into 4 or 6 meters below the surface. So depending on the situation, but I'm always starting with an EMI survey, giving me a rough indication of the site. Then on all of the sites, nearly all of the sites, I have been doing resistivity. That is usually the RM15. Usually it is a resistivity survey with just one fixed electrode separation, but sometimes I am using an ERT with multi-electrode separation, so you get a more depth information on the site. There's one site I have not done resistivity for, well, location-specific reasons. Then I'm doing magnetic, so magnetometry on most of the sites. And as you can see, the sites that I have not done, most of these sites are urban sites. So sites within an urban area, within a city, within a build-up area. And because these urban sites, there's so much metal around, there's so much metal spread in the soil, there's barbed wire, there's metal posts all over the place. It is just not worth doing magnetics because it is too disturbed from a magnetic point of view. So I did not do the magnetics. And the other parts down there I have not done for site-specific reasons. In the last column, I am sort of scoring the results of these surveys. Well, there are 2 sites that did not produce any archaeology. We'll have a look into one of these. The green spots produced some very beautiful maps. So the maps you will find in books, and the maps that you will find on in sort of PR things to get your work presented. But as you can see, most of these, so the orange dots, well, they did produce some archaeological results, but not really very nice maps. And we'll get into one of these examples later. The last one down there, I have no results yet for this because that is still under a survey. I'm still surveying this site. So I've only done the EMI so far, and I hope that this year or maybe next year I can do some additional surveying on that site. A normal field day for us, because these sites are usually rather small, usually 1.5 hectares. Because of these historical maps, we do know where we have to survey. So the morning site, I'm doing the EMI survey on that site. That goes rather quick, doing a 2 to 3 meter separation between the lines. So you can do 1.5 hectares in one morning. That is absolutely no problem. Then we have a lunch break, and the lunch break we take into the field, and that's where I check the EMI data and just have a look at the data, do a quick analysis of the data. And very important, I check the data and see what site is the most important part of it, and that's where I select a location for a detailed survey. And that detailed survey I am taking on in the afternoon, where I'm doing the resistivity and or the magnetometry depending on the location. So that usually takes 1/4 hectare for half a day with a standard electrode spacing. And of course, this it's not possible to do ERT in this very short time. So that is then the project is extended, and I have to do additional work. But since this is more or less standardized work, the report writing is also standardized, so we can get very quick results in the report, which is very helpful for the for assistants. Well, just an example of a very nice result. This is a castle location, and here you'll see a historical map. This is a map from 1713, and the map really shows in the middle a square location, a square moat. There's no castle in the middle, so that is quite dodgy. There's no castle visible on this map from 1700. I did an EMI survey, 1.5 hectare. And this really produced some high resistivity and low resistivity, but there's right in the middle this circular structure that sort of indicated the location of a castle. After that, I've done resistivity and magnetometry on this detailed site, and the resistivity produced right in the middle a very nice structure of a foundation of a castle with a moat around it, as you can see, with a natural water flow to the east, and some indication of a wall sort of covering the moat, making sure that the moat stays inside the moat and does not collapse. Just to find out whether these walls are from brick or other construction materials, I did a magnetic survey on this site, and as you can see, the center here, high magnetic anomalies produce the results, therefore indicating it is a brick foundation, and also part of the containing wall of the moat is also giving a magnetic anomaly. Therefore, I could conclude that this is also made from brick. So that was very helpful, and therefore we were able to make this interpretation map showing the location of the castle, the location of the moat, and the location of the containing wall of that moat. So that is a standard project as we're doing, and this was 1 day work in the field. Well, like I told you, not all the results are very good. This is a large site that I've done. We were looking for a monastery, so there probably, was not even sure, but probably there's a monastery on this site. I made the conclusion that the white parts was absolutely useless to try to do geophysics, because the sites were raised or lowered, or there were modern buildings on top. So these sites were not surveyed. Only the sites that are surveyed were considered worth surveying. And out of this, I could not really see a site that would be a medieval monastery, except for the one up here in the northeastern part. That could be maybe something, and I zoomed in on that with resistivity and magnetometry, which sort of produced a similar sort of structure, but not really convincing of some built structures. Magnetic, it was totally empty, so no solid brick foundations. And well, we took the historical map, so this is a map from 1800, and well, we knew this before, that there was some sort of farmyard on that site, but our hope was that this farmyard had some monastic predecessors that would be a bit larger than this, but unfortunately it wasn't. So this is a site where we did a lot of work, and we tried a lot to find a monastery, but we were not able to find a monastery on this site. Well, then we have these medium results, and with medium I mean the images are not really very beautiful. It's not really worth trying to make a nice painting out of it. But it did produce some archaeological results, and in the end, that's what we are doing this for. The goal is not to produce some nice maps. The goal is to produce an answer to an archaeological question. I'm not going to say all of these examples with you. I'm only picking out one, this number 3. I'm going to take a look at in close detail. So this was a castle, a medieval castle was expected at that site. I had done an EMI survey on that site, and as you can see within the red contour, not everything was surveyed with the EMI. There's a reason for this, because the site that was not surveyed is a glass house, and in this glass house there's a lot of metal. It's all metal everywhere. I tried just a small piece inside, but that was only noise, so that was absolutely useless data. So I did not bother continuing with the EMI inside the glass house. So I only did the site outside, and we sort of found some structures of low resistivity to this site. And this here, you see there's a later excavation, and they produced a large moated structure. So that really was a very nice fit. Well, EMI did not work within the glass house, but resistivity does. So I carried out a resistivity survey inside the glass house, as you can see in the photography. And it did produce some high and low resistivity, although not very clear because of all this food for the plants that are in there. So that really is changing the soil structures inside these glass houses. But there was a very clear indication that low resistivity in this area is a sort of, well, homogenized area of the moat in the excavation. So that really worked together. So that I can't really say that we found the castle, but we found a sort of location of the castle. Outside the glass house, I did some magnetometry. And this magnetometry did not produce the moat, of course not, but it did produce a very strong magnetic anomaly down here, just outside the influence of the glass house, and that, in combination with the excavation that was taken on afterwards, it really showed very nicely the brick foundation with the forecourt for this medieval castle. So. As you can see, the images are not very nice. It's full of disturbances from this glass house, from all of the modern structures around it. But looking at the archaeological question, it did produce some results, and of course that is what we are working towards. Well, we've got some very good results as well. So it's not only these bad results. We do have some very nice results. Here are some of the nice results we have produced over the last couple of years. I am going to take just one example that I took on last September. So that's from a couple of months ago. And again, well, you can see the pattern, that the way we work, doing the whole area in EMI. In this EMI, we were expecting a monastery at that location. So within this EMI, we could see a sort of square structure here, but very vaguely square structure, and I did resistivity and magnetometry in a 50 by 50 area right here, and it really shows very nicely the inside structures of this monastery. And this is the church part and the northeastern corner of the cloister. Also very visible within the magnetometry data, and this is at the bottom, you will see a sort of conclusion of this map. I'm still hoping to extend this survey, depending on the cooperation of local people. Well, we'll see what this one will come up with. So that is, so concluding for this way of working. So doing a site first in EMI, the whole area, then zooming in on locations for high archaeological potency, zooming in with resistivity and MAG. That's sort of a 1 day or 2 day field work. Get local people involved, and these sort of projects become plannable and very inexpensive. So it's not a very expensive way to do. It does produce some results, and although we have 15 cases that are not really very nice results, even 7, so 1/3, produce some very beautiful results, and that's not too bad for a 1 day's work, I would say. So thank you very much for your attention, and I am looking forward to the next presentations. Thank you very much.
Yeah, Sergey Lvovich Smykalov.
Yes, it's not a question, it's just my impression. 22 minutes, 5 years, systematic investigation, different methods. I'm impressed. So only great,
Thank you.
great work.
Thank you very much.
We have a question here. Alexei.
Thank you very much for your presentation. I have a technical question regarding the slide number 14. There is a castle, Neb, yes, for 14. And the second picture, it is zooming in with the activity. What did you do to have this clear picture of the structure?
Well, the left-hand structure, this is EMI, and EMI is also measuring resistivity of the site, but not really very detailed resistivity. And this middle image is proper resistivity with high resolution. This was a 1 by 1 meter sampling. So we have the electrodes onto the soil, actually making contact with the soil, doing resistivity. And that simply produces much sharper images, much better images, showing individual walls in contrast to the EMI that sort of indicates, well, this is an area where you will have walls, not showing the individual walls.
Yes, of course. Thank you very much.
You're welcome.
Thanks a lot. Are there any other questions or short comments? No. Thank you so much, Joab. I hope that you will be staying with us. Yeah.
I will be staying here with you for another hour, but after that, I'm sorry, I have to leave. I have to give a visit to an archaeological site here, and I have to show some people to that archaeological site. But I wish you all the luck with your conference, and I hope to be there next time.
Thank you so much.